So today we want to explore making a speech recognition tool. We are going to use Python for this, and we're going to build an overlying controller using OSC so that we can remotely access, run, and then record audio without having to stop the processes that we're in. We're going to use the creative masterpiece that is Paint here. So what we're going to do is we're going to start off with a header that is going to be the controller, and that is going to send OSC commands into Python, and Python is going to start another thread that listens, records, and then returns audio, where this will where's my mouse gone? Recognize words, and then that will be sent back via OSC into our controller. So it's very simple, but we have something that is able to trigger starting and stopping of our audio processor. It will also be able to receive and decode any words that we do recognize. These OSC messages will go into a Python script that will be able to listen, record, and recognize words inside audio using a bunch of speech recognition libraries. Once it's recognized words, we'll then send it back into our controller, where we can do whatever we want with those words. So that's the general idea of what we're doing. First thing we need to do is get set up with Python. So I've got the 3.6.4 64-bit installer here, which I'm going to install. I'm also going to rerun the installer after it because I don't think I ticked the include in path, because we are going to do a bunch of our tests and installing of libraries using command line, and if we've not included it in the path, it's a bit of a hassle for us to go and set up ourselves. So maybe it'll be a learning experience for us either way. So I'm going to go to system variables, and I'm going to edit the system and variables. I'm going to go to environment variables, and inside path I'm going to edit it, and inside here we're looking for, we want where we just installed Python to be. So I am going to new, and then you have the fun job of digging for your Python installer, which I'm pretty sure is in computer users app data local programs Python 36, and then we want to select that. So I'm going to do new browse this PC local disk users user app data local programs Python 3.6. Okay, that should work. So we push OK to that, we push OK to that, and to test it is installed and recognizing the path, I'm going to open command prompt. I'm just going to type Python-V, and what this should tell us is that we're using Python 3.6.4, so that has recognized that we've included Python into the system variable path, and we're also able to work. Now if I load up this, we are going to be using speech recognition Python. We are going to be using this library here as our main tool. And if we scroll down, we can see it's able to use a bunch of APIs such as Sphinx, which works offline. That's a really cool one. I probably won't use it for the tests as it takes a little while to set up because you can use keywords and stuff to trigger it. Google Speech, which is the default one, and Google Cloud Speech API, which is much stronger and much quicker at recognizing words. And things like WitAI, Bing, and Howdify all require special keys. Bing, I can't even find access to it anymore. Snowby hot word detection is really powerful, but that only works on Mac at the moment. So first thing we're going to do is I'm going to do python-m pip install speech recognition. What that's going to do is requirement always satisfied speech recognition. Okay, so I already have speech recognition installed. Another thing you're also going to need to install is py audio, Python audio. It's again, it'll say that I've got this satisfied, but it's something you need to be able to recognize a microphone inside Python. What else are we going to do? We want to use OSC, so Python OSC. We can see it's called Python-OSC, so I'm going to pip install Python-OSC. And all of these things, you shouldn't need to do anything different apart from set up and install Python on your machine for it to start working. Instead of you getting a requirement already satisfied, it'll go through and it will tell you, there'll be like a progress bar that shows you it downloading and then installing it. Any errors you get in there, please just search them. Things like Stack Overflow show you really simple solutions to it when you're installing software like this using Python. I can't think of any other requirements we have, so that should be enough for us to get started. A way to test it is if you type Python, that will launch into Python, and we can test that these modules are there correctly. So I'm going to import speech_recognition. It moves to the next line. It doesn't throw me up any warning, so I'm going to presume that that's okay. And then I'm going to import Python_OS-OSC. We don't want the dash in there, so we just want Python OSC. And again, it moves to the next line without any warning, so we're going to presume that those libraries are installed correctly. Developing for Python inside command prompt isn't the easiest thing that you'll ever try and do. So I would recommend using Notepad++. I'm pretty sure this works cross-platform, so you can get it on Mac and Windows. But after installing Python, it also installs something called idle for you. If we find it inside here. Yeah, so Python 3. If you go to Python 3.6, you'll have something called idle, which is a development shell for Python inside. A development shell for Python that comes with it, but I prefer using Notepad++, which I'm going to create a new one off here. So I'm going to open Notepad++. I'm going to close that. So I have a new Notepad++ that we are going to use for the majority of our development. Before we move on to make the controller for all the OSC in and OSC out commands, we're going to focus on this Python audio listening section first. So we're going to develop entirely in Python using the speech recognition library, and then we're going to go back and add in the OSC controller after. Because this is the most important part of it. We want to make sure that this is working before we go and fiddle about with adding extras. So let's start working in Python and make our speech recognition library. Before we start, I'm going to set up something inside my Notepad++. I'm going to go into run, and I'm going to push the browse. Navigate to your Python 36 folder and select python.exe. And then you're going to want to include this after. So I'm going to do python.exe space -i, and that's going to keep command prompt open regardless of whether the Python command is running or not. And then I'm going to include speech marks, $, open brackets, full underscore current underscore path, just as you can see on this answer over here. And all that's saying is that it's going to run Python 3.6 using the full path of the current file that's open in Notepad++. I'm going to save it. I'm going to give it a bizarre command, like I normally use Alt-S. When I do it, it's going to say there's a conflict. That's because I already have this shortcut made. Give it a name, so test, push OK, and then that means every time that you push Alt-S, it will run your Python command. Obviously, we have a blank scene, so literally nothing happens. And then let's go back to the speech recognition library and look at its library reference. I'm going to go to speech recognition, go to examples, and then there should be one in here that we want for purely just something really simple: background listening, counting, English, microphone recognition. Let's have a look at this one. So what does this do? It opens up a microphone using the speech recognition library. It opens up a microphone as the source, listens to it, and then gives us a bunch of different results based on lots of different speech recognition APIs. So the first thing we're going to do is just test our speech recognition is working. So I'm going to import speech underscore recognition as SR, and we use that. And I'm just going to set my language to Python inside Notepad++ as well. And we use commands like this. So import speech recognition means we bring the library into our Python code, and then as SR just means we can refer to it as shorthand SR rather than having to type this whole command. I'm going to do R is equal to SR, so go into the speech recognition library and make something and start the recognizer function. Recognizer is what is actually going to decode and run the speech recognition on the audio it hears. And then I'm going to do M is equal to sr.microphone. This is another function inside speech recognition that starts microphone using the Python audio library that we downloaded. We're going to with M as source, audio is equal to r.listen source, and then I'm going to print audio. So what we should happen here is when we run this, it will start and import speech recognition, start something that can recognize, open a microphone, and then use that microphone to listen to some audio. And when we print audio, we're not going to get any text, we're not going to get any recognized words, we're going to get a memory location that says it has successfully recorded audio. So I'm going to do my command, Alt-S. Okay, there you go. Make sure you save the sketch before you run it. So Command S and then Alt-S, because otherwise it will only run the last saved version of it. So by not saving it, it just means I was running a blank sketch over and over and over again. I'm going to introduce a bit of print listening. Just because these don't have prompts, I want to make sure that I can tell when it is actually listening and when it's not listening. So I am going to command save, testing. So what I also have noticed is my laptop is making quite a lot of noise at the moment, where the microphone that this will use, it'll just be the first default in the list and I have nothing else plugged in. So what I'm going to do is I'm going to add a condition, because if we look at, if I go back to GitHub and then we go into reference, library reference, and find listen, we can see here in the recognizer instance, which we have named as r dot, we can listen, and we can also set a timeout and a phrase limit. So I'm going to do phrase underscore time underscore limit is equal to 1.0. So it's going to listen to a 1 second phrase. So now if I save that and run it, testing, there you can see that although it might not have got my full phrase, it returned an audio object or an audio data object, which means that the speech recognition library and our microphone, so Pi Audio, are both working correctly. So we can move on. So next thing we want to do is we now have a variable called audio that is our audio data. We're going to use that to recognize audio. Recognize the speech. We're going to put this in a try loop just because if the recognizer times out or it can't recognize what you've said, it would never tell you and it would never do anything. So we put it in a try except loop to make sure that we can catch errors and understand what's going wrong. So I've got try except. So I'm going to do try print data is equal to r dot recognize underscore Google audio. So what we're doing here is we're saying try to make a variable data by running the recognize Google function inside speech recognition using our audio data as the audio data inside of it. And if we go over here into this, we can see we have the ability to use recognize Sphinx, recognize Google Cloud, recognize Wit, etc. for all the different speech recognition APIs. Looking at Google, we need to pass it audio data, an audio data instance which we know we've already created. It is specified by a key, but it also uses a generic one out the box. It should be okay for testing purposes, but Google can basically refuse access to it at any time. Normally, as long as you keep your references to under about 50 an hour, I've never had any issues. As you can see, if you do go and get your own key from Chromium, the quota is 50 requests per day, and there's no way to get more than that. The other option would be Google Cloud, where you can have infinite access, but you need to pay, and it's a more complicated process. So for what our purpose is just now, using the recognize Google function will work perfectly fine. What we're going to do though is we are going to make exception captures for these two, which are the errors it can return. One is unknown value error, means that it didn't understand what you said, and a request error, that means that Google probably refused to accept our connection. So if you look down, so down here is the try except loop that they use in their example. So all we're going to do is we are going to print data. So that should print the words that we have said. And if not, if it's speech recognition dot unknown value error, print we didn't recognize the phrase except sr dot request error, print no access to the API, check internet. Try again. So the first one says that it wasn't able to understand what we said. The second one returns saying that it couldn't connect to the API, so check your internet, you might not be online, or try it again later. So now if we run this, we should have an outcome that is either data, the words that we have said, it'll print we didn't recognize it, or it'll give us no access to the API. So I'm going to save it and I'm going to run it. Hello, my name is Michael. Oh, I'm also going to increase my phrase here actually. So I'm going to say 5, save. My name is Michael. And there you go. So it feels like there's a bit of a delay at the end there because it's waiting for a phrase of 5 seconds after it hears me start talking, which means that it will have started recognizing the phrase and then it'll have waited until 5 seconds after I'd started speaking, regardless how much I said, before I actually stopped listening. So that's a great result. Now that we know that we can start, listen to, and then decode speech. So for a tutorial, that is a speech recognition lesson done. But we want to make something more advanced. So we're going to introduce a controller. For that, I'm going to open Touch Designer. And I'm going to make, so just purely for testing purposes, I'm going to make an OSC in, an OSC out, and let's do 7,000 in, 8,000 out. And then we want to make a bunch of text commands. So we're going to do start, stop, and I'm also going to do something called calibrate. So in here we are going to do, what's this called? Operator OSC out 1 dot send OSC, and I'm going to send out a command called start listening. I'm going to give it a value of 1. The value for this is actually arbitrary because it's not going to be used by the program we make at the moment. Edit content, so I'm going to do one called stop listening. Stop listening. And then finally we're going to do one called calibrate. So what I am going to do is I'm actually going to start a new Python. I'm going to save it as, and I'm going to call this OSC check, because we're using another library. We want to check it's all working before we combine them. And I am going to import Python OSC. And instead of importing the whole library, I'm actually just going to import a bunch of sections from the library. So I'm going to do from Python OSC import dispatcher. So the dispatcher is something that allows us to catch and then map inputs from OSC correctly. Again, I'm going to set my language to Python. From Python OSC import OSC server. So this is the part that allows us to create and send OSC messages. Python OSC import, we're going to do OSC underscore message underscore builder, something that allows us to package OSC messages, so a command and then a value. And then finally from Python OSC, import UDP underscore client. And this is the part that will allow us to listen for messages rather than just send them. There's also one more thing we need to do from the main Python, and that is import parse. And this is just something that allows us to properly understand messages that have come in. You can look into these libraries a bit more detail yourself if you want to find out. But so the first thing we're going to do is we are going to if underscore name underscore is equal to underscore name. So we're about to define a bunch of functions and uses that map the OSC messages properly. But what we are doing here is we are saying if you are the main thread of the Python program that's running, then we want to set up the catching and sending of OSC messages here, because that one is always going to be running while the Python program is running, even if we do start and close other threads in the background. So I'm going to do client is equal to UDP underscore client dot simple UDP client, and then we are going to send on IP send port. So we need to make two variables. IP is equal to 127.0.0.1, e.g. your home address. And we're going to do send port is equal to, what did we set it equal to? In is 7,000. And then we're also going to use one later called import is equal to 8,000. So we set up a UDP client using simple UDP client in the UDP, the Python OSC library, and this is what we are sending OSC messages on. And then to receive them, so set up server to listen for OSC messages. We are going to use a slightly different thing in here called server is equal to OSC underscore server. So using the other library that we brought in, dot threading OSC UDP server IP import comma dispatcher. Dispatcher is not something that we've made yet, but we will use it in a second. Print serving on dot format server dot server underscore address. So these are all functions that you can find inside these libraries that we're using. Server dot serve underscore forever. So to set up something that constantly listens, we're starting a threaded OSC UDP server. That means that another Python process will start underneath this that is constantly listening for messages, and when it hears them, it will broadcast them. Serving on, so I'm just going to save this. I'm going to run it, and it's okay, brilliant. So it's not throwing up any errors yet. So you can see that we get the message that is serving on 192.0.0.1 on 8,000, and it will constantly listen for it. Now we need to build something that is able to receive any messages it gets and properly route them. And that's where the dispatcher comes into it. So I'm going to do catches OSC messages dispatcher is equal to dispatcher dot dispatcher. So we're just creating a new dispatcher instance. I've been looking at the word dispatcher too much, that is starting to look wrong. Dispatcher dot map. And then this is where we create all the variables that we want to listen for. So one of the examples was calibrate. And then we tell it what we want to do when it receives it. So I'm going to do something called calibrate threshold. And now what this is going to do is if the OSC server catches a message called calibrate, regardless of the variable, it will go and look for the calibrate threshold function, which we need to create before the main. So I'm going to define calibrate underscore threshold unuse underscore other save that. So all it's going to do is, the function at the moment is if it receives the calibrate message, it's going to run the calibrate threshold function that prints calibration received. Run it. No errors are received. So in here, I am going to test sending calibrate. Run script. And it says calibrate received. So we know that it has started the receiving and the serving server on 7,000 and 8,000 respectively. It has then sat and listened, and every time it receives the calibrate message through OSC port 8000, it will run the calibrate threshold function. So now we have multiple threads of Python running in the background with a control system over the top that allows us to go and trigger functions inside of it. And if you are wondering why we're not building all of this in something like Touch Designer or MaxMSP, it's because the inability to thread the recognition of the voice. So when we get to the start of the voice recognition, it would lock up a process like Touch Designer entirely, a process in Touch Designer entirely until it recognized it. This way, we can start an external command hidden from everything, so it runs completely silently and then passes back in the data it's receiving without interfering with what we're doing. One more thing we want to test is just to make sure that we can actually send OSC messages correctly. So what we are going to do is we are going to, when it starts up the server, and we receive calibrate threshold, we are actually going to send back client.send_message OSC command. So you would just do calibration, comma, and then I'm going to send calibration commenced. So now every time the calibrate threshold function is run, it will print into the Python command line calibrate received, and it will send back on port 7000 calibration commenced. And we should see that here, all things running smoothly. No, I have only one usage of each socket address is normally, let's have a quick look at what is going on here. Oh, I still had the old one open in the background, so I got really upset when I tried to send multiple things onto the same port. Run calibrate received. So it runs it, but we don't receive it properly. Oh, that's the OSC out. Here's the OSC in here. And there you can see that we've got calibration received. Calibration, spelled wrong, commenced. There you go, everyone's human. Calibration commenced. So now we have an OSC system that can constantly listen for and run functions based on what OSC command comes in, and then it can send OSC messages back out based on what it hears. And if you haven't worked it out, I'm sure you can guess on what we're going to do now. So I'm going to split this off into a second window, move to other view, and then we're going to combine these two. So I'm going to list this as OSC variables and libraries, and then we are going to introduce our speech recognition lib. So we want import speech underscore recognition as SR. R is equal to sr.recognize R. M is equal to sr.microphone. So the first thing I'm going to do is, if we look at the speech recognize in here, there is something we can do called adjust for ambient noise. And that's exactly what we're going to do. So we're going to calibrate the audio listening device, the recognizer, so that it has a threshold of what it will and won't listen to. And that means that it will start ignoring my fan noise on my laptop. As I was saying, it's quite loud. It means that it will only listen to when we break that threshold. So inside here, when we receive the calibration, we want to so we still want to send a message saying calibration commenced, We then want to try, because we're opening the microphone, we don't want to be stuck without it, with m as source, r dot adjust for ambient underscore noise source, and then using that library that I was, or using that reference I was just on there, I'm going to set the record duration for 1 second. So when it receives the calibrate threshold function, it's going to open the microphone, listen for a second, and then set a new ambient level for the recognizer. And then my accept is just going to be a keyboard interrupt. Print keyboard interrupt received. So this means if something goes wrong or I want to cancel it, I can use Control C inside the Python window to stop this operation if for some reason it gets stuck. And after here, let's client.send underscore message. Calibration minimum threshold set to format, and then there is now a variable inside the recognizer called r.energy underscore threshold. So now that should send a message back on the OSC called calibration minimum threshold set to, and whatever the new energy threshold for the recognizer is. Save it, run it, end of line, keyword interrupt received. Oh, I missed a speech mark. So it's now serving. We open up this, run calibrate, calibration received, minimum threshold has been set to 800. I'm not sure what value it runs in, but on a noisy room I've had it go anywhere from 800 to 6000, and using a really focused shotgun mic, it's about 90s values of 90 value of background noise. I'm just wondering if it tells us in here actually. The energy threshold for the ambient level, so it doesn't tell you what value it is. I presume it'll just be something of sort of like noise value of the audio that it's hearing. And just as a note, we used a second, but it says half a second is needed to get at least some sample of audio clip. Right, okay, so now we have something that we can run and calibrate our threshold so that the audio listening is at the right level. Next thing we want to do is dispatcher.map start listening, start listening. So exact same as before, we're going to define a new variable, or a new function, sorry, called def start listening. So in start listening, we want to print started listening. Client.send message started listening thread started. So I'm sending both print and OSC message here just so that I can prove the debug is working on both ends, and you can try and work it in parts where something is going missing if it is. And then we're going to open the microphone again and start listening for an audio file, but this time instead of using just listen, we're going to use the listen in background command that starts another thread of Python. That means that the listener is always active in the background, and it returns a callback that is the values of anything it's recognizing. So we're going to introduce something called a stop listening variable .r listen in background. M is our audio source, and callback is a function that we're about to make return. So if up here we need to make a new variable called stop underscore listening, we need to import it. I'm going to set it to none, and then in here we're going to import it as a global variable, so global stop listening. And this just means that when the listening thread is started, it starts something called it returns a function object that is basically it allows you to go and stop that thread. So by changing this global variable, it means that we can stop this other thread from running if we ever wanted to close the audio. An example of that would be is when we want to use the close button, or you want a moment of silence in your function. So that's why we made the stop button, and that's how we introduce this here. So now, as we see here, it recognizes the exact same mechanism as the listener, normal listener. You can add all the same commands, but this time it means that we need to have a callback that handles whatever this thread is sending back to the main thread. So up here we are going to define callback. It's going to have two variables, the recognizer and our audio. We're going to print data received from thread. So this will only activate whenever the thread sends recognized an audio data file back in. And we're going to use our try except loop. And this is going to run the exact same way as it did when we were testing over here. So I'm actually just going to copy it. I'm going to select it all and push T to tab it in because we're inside a function now. And then we want data received from thread. It's no longer called data, it is called so we want data is equal to audio print data. Didn't catch that. Error 1, error 2. So under here we want to client dot send message data. So now this will send back the recognized data from Google, print it out in Python, and hopefully send it back to Touch Designer. So let's save that and see if it runs. Callback only one socket feature. I've still got Python open. I'm really bad for that. So it's receiving. We are going to run start listening. Hello, my name is Michael. I'm actually going to stop it, save it, and I'm going to run it again. But this time I am going to introduce the calibrate run. So it's received. The minimum threshold is 1600. We're going to start. Hello, my name is Michael. And there you go. So now it's actually still listening in the background because we haven't set up the stop command yet. So if I speak loud enough into the machine, you'll see that it's continually receiving data. Now this might return a really, really long string. Because we haven't set a limit on the sort of phrases it can listen to, it means that it's listened to everything that I've said. for the past X amount of time, and it's actually trying to recognize that really, really, really long sentence or paragraph essentially that I spoke. One way to avoid that is to introduce something in here. So data.recognize listen in background. We'd want to introduce something like time phrase underscore, what is it? It's called time underscore limit. Let's say it so a phrase can only be 5 seconds long before it cuts off and sends back. This is a second test of a 5-second phrase. This is a second test of the 5-second phrase. And there you go. We can see that it is running and it's capturing 5-second phrases way more accurately than it was before. When I am doing these tests, just as a heads up, I'm moving to and from the microphone on my laptop. And that's different from the microphone I use to record these videos. So it might sound bizarre to the video, but I promise you I'm speaking into my laptop here. So the final thing we probably want to do is add a dispatcher.map for stop listening and then stop underscore listening. So the final thing we need to do is the ability to stop listening. So I'm going to define stop listening. I'm going to import that global variable that is stop listening. And that is basically a directions to the thread that has started for the listening. I'm going to print stopping, and then I'm going to client.send underscore message stopped listening stopped microphone thread. And then the final thing we want to do is call the stop underscore listening function, our object in this case. And if we look at this, it has the wait for stop variable, wait underscore for stop equals false. And all that's saying is that you can hang the entire main thread while the external one is stopping. But in this case, we don't need it because the Python is always going to be running underneath. So if I save it, test it, stop listening is not defined. Stop underscore listening, save, run. So we can now calibrate. Test message 1. Test message 2. And then I'm going to stop it. It'll say stopping. And in here, I now have a history of all of that. So you can see that we started it, if you ignore everything from 4 up. So we calibrated it, we set the minimum threshold, we started listening, we got in text message 1 and text message 2, integer, and then word. You'll notice that I actually said test, and then stopped listening, so stop the microphone thread. And now if I'm speaking way into my laptop, you can see that it's not registering data received from the thread. And then it's up to you what you do from here. Obviously I'm not going to show you how to route OSC messages inside Touch Designer or Max MSP, things like that, but that is the start of well, it's not the start, that is a machine that starts a Python command silently, allows you to then listen for OSC messages that trigger various things involving speech recognition. And inside here, you could use that to trigger whatever you want, whether you want it to be like your own Amazon Alexa or something that allows you to just speak to a program or do something cool. I hope that's been helpful, and I'll see you in the next one.